Welcome to today's lesson. Today I'll be looking at forces acting on structures and machines. Okay, so we're going to be looking at forces acting on structure and what machines. What do you understand by the word force? A force may be a pull or a push. That is something to change the shape or the movement of what an object. So that is the two aim of what a force. In every structure, there are forces acting on them. We only feel the effect of these forces based on the size of the force, the direction of the force, and then the location where the force is applied on the structure. When I'm talking about structure, I'm talking about structures that are designed like your bridge, your building. You know what I'm talking about? Yes. These structures must be designed with enough strength to support and withstand forces that will be acting upon them. What are the forces acting upon them? Every structure has two types of forces acting upon them. There are internal forces and what? External forces. When we talk of external forces, we are looking at forces acting outside or against what? The building. Some of these forces are natural, some are what? Created. For example, we look at the natural forces as a result of what? Wind, okay, hailstone, all right, tsunami, earthquake, and all that. And then we look at the other one, such as gravity. Okay, gravity occurs because this bridge itself is designed using what? Materials. Now the materials generate what? Weight due to gravity acting on it. This is also an example of what? External force. But we'll look at the effect of gravity. Gravity is a result of the Earth's mass pulling all objects towards its center. Is it not? Yes. The more you go higher from the Earth, the lesser gravity what you experience. Is it not? Yes. Engineers, where they are designing, they try to design buildings that will stand test of what? Time. Let's look at the internal forces. Internal forces are opposite of what? External forces. Why? They are opposite of external forces because they act within the building or the structure, and they always oppose what? The external forces. There are four main internal forces that you must know. There are compression, tension, torsion, and what? Shear force. Okay, when we talk of compression, we are looking at the pressing or squishing of materials together, usually a what? Downward force caused by what? Gravity or pulling of other materials onto what? A structure. So compression is a force that pulls material closer together. While we look at tension, we're talking about the pulling apart or elongation of a material. The material can only stretch so far before it rips apart. So the tension of a material depends on the kinds of material, all right, and the strength of the what? Material. So tension, which is a force created when a material is stretched, as you can see, is an example of what? An internal force. Torsion is when a material is twisted. It can be twisted in opposite direction from both ends, or in one direction from one end. The best way you can remember tension is when you are washing your clothes. Okay, that's an example of what? Torsion. All right, it's an example of torsion. Is an internal force. The last one I'm looking at is the shear force. A shear force is when two parts of a structure push or pull in a sliding motion in opposite direction. Usually perpendicular parts of structure experience the most shear force. So I'm saying, look at the diagram by your right. Is it not? Yes. When I'm pushing this one upward and this one is coming downward, what they are doing, they are sharing what? A force. Shear force helps to reduce external force on what? On a structure. Okay, that is the basic truth. One thing we must know about withstanding forces is that for a material or a structure to be able to withstand forces, its internal forces must be greater than what? External forces. Okay, in general, forces acting on the structure can cause them to fail to perform their function. Failure can occur if the force is too strong for the structure's design, or if the forces is acting on a vulnerable part of the structure. Take a look at this boy. This boy is able to sit on this chair because the forces or the internal forces are strong enough to balance the external force, which of course is the weight of the boy, exerted as a result of what? Gravity. Okay, so when the boy sits on this chair, the shear will, because of the foreleg, will generate the shear force, is it not, and distribute the weight to all parts of what? The chair. Therefore the chair will not break easily. But let's assume we put one leg at the middle and the boy sit down with all his force. What happens to the leg? It gets broken, is it not? Why? Because all the forces are directed in one direction, and then the forces of the weight are not shared equally among the structure, which of course is the shear. So it's very, very important when you are designing, you consider all these what? Forces in order to withstand what? External forces. Okay, engineers use the knowledge of forces to create designs that will most likely prevail during what? Structural failures. Okay, so they try to design in a way that their structures will not fail. How do they do this? They do this in basically 4 ways. We are designing, they make sure that whatever they are designing, that there is a distribution of the load, so that not one part or no one part of the structure carries most of the what? The load. Like I said just now, you see that boy using 4 leg of shears. When you sit down, which of course is the load, your load or the force will be distributed equally. So it makes it much more what's it called, less difficult for the shear to withstand what? Your weight. Another thing engineers do is that they direct the forces along an angle component, so that forces hold pieces together instead of pulling them apart. This is another design they use. There are some designs that you come across, you will see something like a triangle. Okay, this triangle are made of rod and they help to hold a building. Look at the roof of many buildings, they are designed like that. The reason why they are being designed like that is for them to generate enough internal force to counterbalance or to act against what? External force, and keeps the structure from what? Failing. Another thing engineers use is that they shape the parts to withstand what? The specific type of force acting on them. Okay, if you've come across one of the finest building or the finest hotel that was built in United Arab Emirates, you will understand the importance of what? The shape. This structure was built in water. Okay, and the engineering design included shapes, so that when every wind is coming, it will be able to divert this air, okay, without actually was damaging what? The structure. And then they try to build it, giving it the best shape. Look at ship, for example, walking, or when a rudder is what's it called, directing the ship on sea. You see the shape of the ship, is it not? That shape is designed to what? To counterbalance what? The drag. Do you get it now? Yes. Choosing the correct material is another, or the 14 engineers consider. For example, like I was saying, when they were building that structure, at first they were using concrete. It got to a level they started using glass and what? Metal. Why? Because they don't want to give it more weight at that height. If you have too much weight at a very tall height, what will happen? It will be dragging the building, and then the building what? Will fail. Is it not? Yes. So these are 4 things engineers and you and I must consider when creating what? Our what? Structure, so that it can withstand what? The external forces. Okay. There are forces of a natural world phenomena. Okay, these forces of natural phenomena, they include earthquake, hurricanes, all right, volcano eruption, heat wave, cold fronts, and other sudden weather changes. Okay, engineers, when they are designing, they ensure that whatever they are designing is able to carry these forces should in case they happen. Okay, for example, in the United States of America, before a building can be constructed, they will test it using simulation, I mean computer, with all these forces, and see how it will work. Okay, if the building will stand it, they will not start constructing it, but if it doesn't, they will abandon that project. Many failures that you have noticed in this country, Nigeria, is lack of testing or simulation. Okay, they don't test most of all these structures that fail. That's why most of them are what? Failing. All right, but you now know that there are internal forces and what external forces, and you must carry out careful analysis to make sure that whatever you are designing overcomes all these what external forces. Let's now look at simple machines. Okay, we're talking about simple machines. We'll look at what a machine is. You know, a machine is a device or an equipment that enables us to do work what more easier or easily. So the aim of a machine is that it enables us to do work what more easily. Okay, simple machine make it easier to move a load. A load is any of the forces that a structure must oppose. These include unmoving force, also called dead load, and any other moving force, which is called live load. So all simple machines function differently. They can either change the direction or magnitude of a force. In general, they are the simplest mechanism that create what a mechanical advantage. So all I'm saying is machines, what they do, they create a mechanical advantage. What is mechanical advantage? Mechanical advantage means for a machine to give you what? A benefit. Do you understand? Instead of you doing it by yourself, you use a machine. The machine will give you what? The benefit. I'm going to explain more on the note, okay? These machines I'm talking about are found all walk of life, and they are classified into 6 classes. Okay, we can use an acronym known as SLIP2W to remember them. Okay, when I say SLIP2W, I mean SLIP then 2W. Okay, the S is for screws, L is for lever, the I is for inclined plane, while the P is for pulleys, and then the 2W are for wedge, and we are what? Axle. So we're going to be looking at these 6 classes of machine briefly and then understanding what they do. Let's look at the first one, which is the pulleys. A pulley is an example of a mechanical system or a simple machine that uses rope which runs between either a fixed or a movable wheel. Okay, the wheel portion of the pulley is actually another type of machine that we call the wheel and the what? Axle. So we can say a pulley is a combination of a rope and a wheel and the axle. Typically, a load will be attached to one end of the rope of the bottom of a pulley, and then the rope will run through. However, many pulleys are what? In a system. So we can have a system where we have a single pulley. Look at the pulley, you can see there. You have come across something like this. Okay, we can have a system where you have just a single pulley, and then a system where you have more than even 3 pulleys. Okay, we'll look at pulleys in our subsequent class. At the other end, you have where you are able to pull the rope to draw out the load. Now, the wheel and the axle allow the rope to move around it with very small friction. Okay, pulley can be used to either reduce the effort that is required to lift a load, or we use it to change the direction that a force is applied in order to lift what or move a load. You see it now. Let's take for example, when lifting a flag on a flagpole, we use a pulley to get the flag high along the shaft of the pole. True or false? Yes, you've seen where a flag is being pinned, is it not? We are dragging the flag so that it rises to the top of the pole before you stand it, is it not? The force applied to the rope is in a downward direction while the flag rises upwards. Without the pulley system, someone would actually have to climb up the pole to raise the flag, is it not? Yes. So you see, it's more easier using the pulley, because that is the essence of machine. It must try to make the work more easier, which is a mechanical advantage. Okay, so we look at some examples of pulleys at work in everyday life include elevators, flagpoles, cloth lines, cranes, weight machines, and then certain parts of a car engine. Okay, the previously listed device all use pulleys in their designs for different reasons. Okay, for example, what the elevator tried to do is to reduce the work on the machine by applying that pulley when you are ascending or descending. So putting less strain on the engine over time, whereas the weight of the machine uses pulley mostly to make lifting the weight more what convenient. I'm talking about what the elevator. Okay, so the second kind of simple machine we'll be looking at today is what lever. Say lever. Now a lever is a simple machine that can help you do many different things. Okay, because lever does many different things, they are classified into three levers. Okay, you have the first class lever, the second class lever, and the what third class lever. Every lever has three major components, although there are four, but they have three major components, right? The three major components are fulcrum, which you also call the pivot, or which gives the support, and then you have the load, which is what you want to overcome, and then you have the effort, which is the force you need to apply to lift the what to overcome the load. Okay, so the way the three important components of a lever are arranged will determine the class of lever it is. For example, in a first class lever, you will have the fulcrum in between the load and the effort, as you can see on this diagram. And then in the second class lever, you will have the load in between the effort and the fulcrum. Okay, and finally the third class lever, you will have the effort in between the fulcrum and the load. So the best acronym to remember this is the word FLE or FLE, depending on how you want to pronounce it. FLE. It stands for the middle of the first class, the middle of the second class, the middle of the third class lever. F means that the fulcrum will be at the middle of the first class. L means that the load will be at the middle of the second class, and E means that the effort will be at the middle of the third class. Okay, so you can actually twist the device, but one thing must not change: the center. Okay, the center must not change. For example, look at the scissors, which is a first class. I can decide to turn the scissors the other way around. I will now have what? My effort, my fulcrum, and my load. Is it not? Yes, but the fulcrum remains the same. So that is how you identify the first class, second class, and the third class lever. Okay, each model above shows four components. What? A fulcrum, a triangle. Okay, as you have seen in a block or pivot point, and then you have the effort, which is the arrow, and then you have a force, which is usually caused by what? Our effort. Okay, and then finally you have the load, which is what we want to overcome. Okay, now there's a fourth one that you need to know, and it's called the lever arm or the line. If I want to explain the line for you, I'll have to use this hammer to explain it. When you hold this hammer, you're trying to use it to remove a nail. The hammer is actually acting as a first class what? Lever. Can you see it? You can see the effort, you can see the fulcrum, and then you can see the load. Is it not? Remember FLE, is it not? F at the middle means it's a first class. So you can see the effort, fulcrum, and then the load. Now the line is this connection from the beginning to the ending. Okay, is another fourth, but is usually not considered that much. The three important ones are what you are seeing here on the lever. All right, how about a wheelbarrow? A wheelbarrow is an example of what? A second class lever. Why? Because the load is at the middle, is it not? Yes, and then you have the effort at the beginning and the fulcrum at what? The ending. The way you place the load on the wheelbarrow will determine the effort you will use. Okay, if you place the load closer to the fulcrum, you will need less effort to pull the heavy load, but if you do it the other way around, you will need more effort to pull the load. Okay, yes, that's the mechanism. Then let's look at the human arm. The human arm actually acts as a third class lever. You see it? The third class lever actually require more force to lift a load than the actual weight of the load itself. So the effort we're applying is actually greater than the load itself. You want to say that, uncle, then this is not beneficial. It is beneficial. Why? Because the distance you are covering is also important. Imagine you have to take your head down and bite, take your head up again, take your head down and bite. You know, that is more stressful. Okay, so that's why it's considered as what? Still a machine or a lever. Okay, so the third class lever actually require more force to lift a load than the actual weight of the load itself. The advantage comes by providing gain distance. Is that not? Yes, that's what I've told you before. We are able to move the arm a large distance with a short word muscle contraction. So you can see the load, the effort, and what? The fulcrum. You can see the arrangement there. That gives you what? A third class lever. We now look at what? The inclined plane. Say the inclined plane. Inclined plane is actually a surface that is raised a little at an angle. Okay, what it does is that it is a flat sloping surface that is used to make the job of moving heavy object easier. An object can go up an inclined plane or down. Okay, let's assume we are building a house. Okay, someone is using the staircase to carry cement to go and give the, what is it called, the builder. Another one decide to put a plank just like what you are seeing here, and then he's using wheelbarrow to roll it easily to the top. Who do you think is using less effort? Of course, it's the guy that is climbing this place. One, the wheelbarrow will help him to reduce the effort. Two, the inclined plane will help him to roll the load quickly, and at the end of the day we'll be carrying more load than even the one climbing the stairs. Is it not? Yes. So that is where the benefit of the inclined plane come in. Okay, another example is when you're trying to carry some load into the back of a truck. Instead of lifting it with your muscle, it's better you just use something like a small way, and create this inclined plane. You easily drag them into the truck. Okay, that is a very good advantage of it. We now look at the third, which is called the wedge. You can think of the wedge as when we combine two small inclined planes together back to back. Okay, when you weld two inclined planes together back to back, you have what we call a wedge. Okay, a wedge is a simple machine that allows a person to push two objects apart, okay, with a very small effort. Okay, the mechanical advantage you get from a wedge will depends on how thick the wedge is. If the wedge is thick and short, it will split things apart more quickly, but you will have to push down on it with more force. But if the wedge is thin and long, it will be easier to drive it in. Okay, but the problem is that it will take longer time to split the material into two. Okay, you can think of the village when they are axing wood. Okay, axe is an example of what? Your wedge. When you use it to tear wood, that is an example of what I'm trying to say. Okay, so some examples of wedge being used in everyday life are your human teeth, which help you to cut through food. The knife, fork, and spoons can do the same. Okay, a flathead screwdriver and an axe are often used to split materials like wood. Is it not? All these are examples of what? A wedge. Another thing your wedge does is that we use it to stop unwanted movement of a packed trailer. If you see some big trailer when they park, you see something like a wedge. Yes, that's another use for a wedge. Okay, so that the trailer wouldn't move forward or backward, it will stay stable. We also use wedge for that. Okay, the next one to look at is a screw. Say screw. A screw is actually a combination of an inclined plane and a wedge. All right, and screw work in two motion. It rotates and then it translates. Okay, how do I mean by rotate? As you are winding it into a material to hold two materials together, it will be winding in a circular path while it is going inside also. So that's what I mean by rotation and translational movement. Screws are unique. Why? Because they can tear through materials that they are what twisted into by using its sharp tip to puncture an initial hole in the material and then using its wrap inclined plane to slowly erase itself deeper. As the screw is driven into the material, it pulls the two separate pieces closer and closer together. That's why I say it's used to hold what material. Let's now look at wheel and what axle. When we talk of wheel and axle, we are talking about two parts of the material: the wheel, which of course is a circular ring usually made of metal, and then the axle, which is a long rod that goes through what the wheel. This lets the wheel turn freely around the axle. You can think of your car tire. Okay, your car tire has an axle that connects the two wheels together. Okay, what does it do? It makes it easier to move heavy objects like the car. Yes, it's the wheel and axle that is carrying the car, is it not? Yes. So it makes it move a heavy object over long distances. Usually wheels and axle are attached to large structures which hold load. Just as what this truck you can see here, is it not? The design of the wheel allows there to be less friction between the ground and what the materials of the wheel. So because of the wheel and the tire added to it, is less friction. Less friction means easy movement. Okay, that is what the wheel and axle does. If a truck has four wheel and axle attached to its body and a large bed in the back for storage, you can place many different items in the back of the truck, and then using the four wheels, the truck can roll along what a flat surface, the road, to wherever the load needs to go. Is it not? Yes, that is how we carry heavy load using what the wheel and axle system. Another one is weightlifting. Okay, you can see weightlifting in practical. When people are doing weightlifting in Olympics games, you see them, they raise up those rods. Okay, so let's look at the mechanical system. A mechanical system is a complex collection of machines and other mechanisms that work together to perform a task. So what I mean is that we'll combine two or more simple machines together. We have what? A mechanical system. A device that has a mechanical system working within it is often called a complex machine. Complex machine consists of two or more simple machines working in what? In union. Okay? An example is what? Your bicycle. If you look at the bicycle very well, you discover that it has more than one simple machine. Is it not? Yes. All mechanical systems have advantages and disadvantages, and there is a consistent trade of occurring between what? The two. Let's take a look at the advantage of this bicycle now and the disadvantage of this bicycle. This bicycle have a mechanical system. So if the rider switches to a very low gear and he is moving, is going to apply more effort. However, that effort will take the bicycle more further. Is it not? Yes. But if he apply a very high gear, he is going to apply little effort. However, that little effort is going to take the bicycle a distance less than that of the initial one. Is it not? Yes. That is the system of this very mechanical device. A mechanical advantage is how much a machine multiplies the effort force put into it. Okay, for example, you can see this man is using a 10 pounds force to move what 100 pounds load. Why? Because it's applying what mechanical system. So mechanical advantage usually give you an advantage of using the machine over human effort, and we can calculate this. If you want to calculate it, you either say it is the length of the arm divided by the length of the resistance arm, that is for the lever, or use a general formula that says your output force divided by what? Your input force. So if I give you a question to calculate the mechanical advantage for me, you simply put your output force up and divide by your input force. Okay, it gives you what? The mechanical advantage. Now you must take note, depending on the value you have. If you divide the output force by your input force and you get a value of 1, it means that the machine does not have a mechanical advantage. You are putting the same effort and you are getting the same load. You get it now? So it means the machine does not have a mechanical advantage. But if you get a value that is greater than 1, it means you have what? a mechanical advantage. But if you now get a value less than 1, it actually means that the machine has a mechanical disadvantage. What I mean is that you are putting more effort to do less work. Okay, so it has a mechanical disadvantage. Now look at this example. In a first class lever that has an effort arm length of 1.5 and a resistance arm length of 0.3, what will be the mechanical advantage? It will be 5. Why? If you divide 1.5 by 0.3, you will get what? 5. So that is the mechanical advantage. I want you to watch this video and learn more about simple machines. Okay?
Simple machines are very basic mechanical devices for applying strength and performing work. Let's see 6 different kinds of simple machines. Wheel and axle. It makes work easier by moving the objects across distances. The wheel turns with the axle causing movement. An example is your skateboard. Inclined plane. It is a flat surface that is inclined, so it can help move objects across distances. Aha! This slide is also an example of inclined plane. Wedge. A wedge is a triangular-shaped tool and is a portable inclined plane. It can be used to separate 2 objects, lift up an object, and hold an object in place. An axe blade is an example of a wedge. Screw. A screw has a long, thin metal shaft with threads spiraling along its length. It also has a turning head with a groove where a screwdriver can be used to rotate the screw. It can be used to lift things or to hold things together. Lever. A lever is simply a plank or ridged beam that is free to rotate on a pivot. It is perfect for moving or lifting heavy things. Pulley. A pulley is simply a wheel with a groove in it and a rope in the groove. It is used to lift up or lower heavy objects. With the help of the pulley system, rock climbers can climb steep rock surfaces easily. Here's a chart of various simple machines. Wheel and axle. Inclined plane. Wedge. Screw. Lever. Pulley. Now you know a lot about simple machines.
What does this code have to do with levers? This is a simple mnemonic device that you can use to remember levers, and we'll learn more about it at the end of this video. A lever is a simple machine, and they are the basis of many tools in and around your house and work. Levers are also found in the human body. The way a lever works is that a force is applied at a point, which moves a load at another point through a balance point called the fulcrum. It's the position of these 3 points, the force, the load, and the fulcrum, that distinguishes the type of class of lever. There are 3 classes of levers: first, second, and third. With a first class lever, the fulcrum is in the middle and the force is on one side and the load is on the opposite end, much like this seesaw. Other examples include scissors. Here's the force, the fulcrum, and the load, and pliers. Second class levers have the load between the force and the fulcrum. For example, with this wheelbarrow, here's the force, the fulcrum, and the load. A nutcracker is an example, and a stapler. A third class lever has the fulcrum on one end, the force in the middle, and the load on the other end. For example, with this hockey stick, this rake is a third class lever, and a hammer. Here's the fulcrum, the force, and the load. Now let's take a look at this easy mnemonic device to help you remember the different class levers. First, you write out FLE, kind of like you're fleeing from someone chasing you with a lever. Next, underneath, write 1, 2, 3. The letters stand for fulcrum, load, and effort, and tells you what's in the middle. The 1, 2, 3 is the type of class lever. So with a first class lever, the 1 is under the F, so a first class lever has the fulcrum in the middle. A second class lever is under the L, so a second class lever has a load in the middle. And the third class lever, which lines up with the E, has the effort in the middle.
Welcome back from that video. I believe you now know the two types of forces that act on a structure. You now know the factors that make internal forces greater than what external forces of a structure. You know the 6 classes of machine, and you know the 3 kinds of levers, how they are all classified, and then you know what mechanical advantage is now. That now brings us to the end of today's lesson. I want you to make sure you do your quiz and other assignments. Stay safe.